This is the story of Lion Air Flight 610. On October 29, 2080, a Lion Air Boeing 737-8 was to fly from Jakarta in Indonesia to Pangkal Pinang. The plane was a 737 MAX 8, brand new. It had only flown for about 37 hours over its first 3 days of operation. The pilots had gone through their training for this specific aircraft just a few weeks prior. Everything was as it should be before a flight. As the pilots went through the pre-flight checklist, they noticed that the indicator light for the angle of attack sensor number 2 was off. They reported this to maintenance and they were cleared to take off. And then everything went wrong. After taking off from runway 29, the pilots turned the aircraft to the left to begin their climb out to their cruising altitude. However, within seconds, they started getting warnings in the cockpit. They had a low angle of attack warning and the max effort warning. Then the stick shaker came on. They were at an altitude of 10,000 feet when the pilots managed to level the aircraft off. They were now at their minimum safe altitude. They needed to climb. They put the engines into go-around mode and started to climb away, but it was too late. They impacted terrain at a speed of 406 knots at an altitude of just 2,500 feet. Above the terrain, they had smashed into the sea. There were no survivors on board the 737 MAX. At first, the investigators couldn't understand why such a new plane would crash like this. This wasn't some old DC-9 with 50,000 cycles on the engines. This was a modern jet airliner. Surely there was something more to this. So, they began talking to the families of the victims. That's when they learned about a previous incident. On October 17th, 5 days before the fatal accident, the pilots of Lion Air Flight 601 also flew a 737 MAX 8. On that flight, the pilots had experienced similar issues as the crew on Flight 610. On that flight, they were able to take corrective action in time, and no one was harmed. The question is, why did the same problem bring down another plane just 12 days later? So we know that there was a problem on both flights. Now we need to find out what that problem was and why it brought down one aircraft but not the other. Let's start by looking at the flight data recorder. The FDR actually stopped recording data prematurely because the aircraft was at a very high angle of attack when it hit the water. But from what data we do have, we can tell that the aircraft was in a very shallow climb at the time of the crash. The aircraft actually climbed just 250 feet over the 1 minute and 20 seconds before the impact. This isn't good. A normal 737 will easily double its altitude in half a minute. Something was definitely wrong here. When we look at the parameters that are recorded on the FDR, we can see that the aircraft was at an angle of attack of 20 degrees when the plane hit the water. For a plane like the 737, this is far too high. This is well above the critical angle of attack, which is somewhere between 15 and 18 degrees. When a plane reaches this angle of attack, airflow separates from the wings, and the plane loses all lift. In some planes, like the 737, this can cause a very sudden stall. But in other planes, like the Airbus A320, this can cause the plane to fall like a stone. Now, you might be thinking, why were they at such a high angle of attack? Well, the answer lies with the trim system of the 737. You see, the 737, like most other planes, has a trim system that keeps the plane stable in the air. Now, the thing about the trim system on the 737 MAX is that it's fully fly-by-wire. There's no mechanical connection from your control column to the trim system. In fact, there's no mechanical connection from your control column to the elevators at all. Everything on the 737 MAX is controlled by computers. The way that the trim system works on the MAX is it uses two angle of attack sensors to measure the angle of attack of the plane. If the angle of attack increases, the computer will move the trim tabs on the elevators to push the nose of the plane down. But what if one of these sensors is broken? What if it gives a faulty reading? Well, in that case, the plane would try to compensate for an angle of attack that's not really there. That would cause the nose of the plane to go up. Remember, if the nose goes up, the angle of attack goes up, which means that eventually you'll reach the critical angle of attack and the plane will stall. That brings us back to Lion Air Flight 610. After the pilots took off, they were climbing away from the airport at a steady rate. Within seconds, the angle of attack sensor number 2, the one that didn't work, sent a signal to the computer saying that the angle of attack was increasing. The computer then moved the trim tabs upward to keep the angle of attack at a steady 2.2 degrees. However, since the angle of attack wasn't actually going up, the real angle of attack was 9 degrees. This meant that the plane was dangerously close to its critical angle of attack. At some point, the pilots tried to correct for this by putting the plane into a bank to the left. This lowered the angle of attack, and the pilots were able to recover from this. But they didn't know how to fix the problem. That was made worse by the fact that the 737 MAX had a very limited envelope for maneuvering. Due to its new shape, the 737 MAX was much more sensitive to changes in angle of attack compared to its older brother. This meant that the pilots had less time to react to the situation and troubleshoot the problem. As the plane was in a left bank, the pilots used the trim wheel to try and correct the trim, But unfortunately, they accidentally selected the wrong trim switch. They were trying to trim the plane for the left bank, but since they selected the wrong switch, they actually aggravated the problem. As the angle of attack increased further, the computer pushed the nose of the plane down harder. The pilots fought back, but it was too little, too late. They reached the critical angle of attack, and the plane stalled. From this point on, the plane basically becomes uncontrollable. You can pull back as hard as you want, but you won't be able to recover from a stall. As the plane continued to fall, the pilots realized what had happened. They had a trim malfunction. They managed to turn the autopilot off and select the alternate trim mode. But it was far too late. The plane was now at an angle of attack of 20 degrees, and it was just 1,000 feet from the ground. There was no way that they could recover from this. In the final moments of the flight, the pilots were heard talking to each other. They said, "We've lost a lot of altitude," followed by, "It must have been the trim." Seconds later, the plane hit the sea at a speed of over 400 knots. One of the biggest reasons that this plane crashed was because of a lack of communication from Boeing and the FAA. You see, when Boeing was certifying the 737 MAX, they decided to not tell the FAA that the MAX had a different trim system. They thought that this wouldn't be a big issue, because the difference was so small, but they were wrong. The pilots on board Lion, Air Flight 610, were never told about the unique features of the trim system on the 737 MAX. Had they known, they may have reacted differently to the warning signs. But the problems didn't end there. Just a few days before the fatal crash, a Lion Air 737 MAX flight crew experienced a similar problem. They were able to correct for the problem, but no one bothered to file a report. Had they done so, perhaps the FAA would have realized that there was a systemic issue with the MAX that needed to be fixed before someone got hurt. The 737 MAX is a great plane. It's efficient and it flies well. But the main reason that it has been grounded for the past 2 years is because of a lack of communication and transparency from Boeing. What do you think? Let me know your thoughts in the comments below. Thank you for watching this episode. If you like the videos that I make, do consider liking and subscribing. It will really help us grow. I will catch you guys next time. Stay safe.